So in this video, we're going to be talking about when to use the efficient method versus when not to use it, okay? So let's say a is 1. Let's say we have x squared plus 11x plus 10. When a is 1, we can jump straight to our factors. We can jump straight to factored form, like this. Because for the first two terms, if I were to multiply this together, the only combination is going to be x and x, because a is 1 right here. Okay, so when a is 1, you can jump straight to factored form. So now we can just look at a times c, or really just c, because a is 1. So fraction of 10 that add up to 11. Well, that would be 10 and 1, right? 10 and 1. So I can say plus 1 here, plus 10 here. So this would be my answer. But you can only do that when a is 1, okay? Let's look at when a is not 1, okay? Let's look at 2x squared plus 7x plus 3. Okay, so we're going to do the AC method, right? We know to take A times C. So A is 2, C is 3 to get 6, and 7 is B. So we know factors of 6 that add up to 7. Well, in this case, it would be 1 and 6, right? 1 times 6 is 6. 1 plus 6 is 7. So if I just jumped straight to factored form and wrote x plus 1, x plus 6, you can see that if I were to check my work when I double distribute, I'm not going to get 2x squared. X times x is x squared. So there's no way I can get 2x squared. So we know we can't do this. So what do? We have to do factor by grouping. So we have to rewrite our middle term with our two new factors that we found. That's one of the reasons why we have the table. So we're going to take our new factors and rewrite our b value. So we have 2x squared plus x plus 6x plus 3. So I'm undoing the simplification when we double distribute. Okay, that's what this step is. Then I want to see what did I multiply that's in common. So we're going to factor by grouping. Group the first two, group the last two. In the first two, I'm looking for a greatest common factor in the first set of parentheses that I grouped. Okay, the first two terms that I grouped together. I see that I can take out an x. What's left over? 2x plus 1. In the second set, I do the same thing. I can take out a 3. What's left over? X plus 1. Oh, I'm sorry, 2x plus 1. Now, a great checking point is right here, okay? Because you want your parentheses to be the same. And you can see that we have 2x plus 1 and 2x plus 1. That means one of the parentheses that we multiplied, one of the binomials that we multiplied, is 2x plus 1. So we can factor this out because it's a greatest common factor. So we have 2x plus 1. Those are going to cancel. What's left over? X plus 3. So these are our binomials that we multiplied by. So this is our answer right there. Okay? Let's do another one. Let's factor 3x squared plus 10x plus 8. So a is not 1, so I know I have to do the long method. I'm going to have to factor by grouping. So if I look over here at this little table, I like to make my table, I like to show my thinking. I want factors of a, c that add up to b. So this is a, this is b, and this is c. 3 times 8 is 24, and b is 10. So what are factors of 24 that add up to 10? Well, that's 6 and 4. So I'm going to rewrite my middle value. So we have 3x squared, my b value, I'm going to rewrite my b value with my factors. 3x squared plus 6x plus 4. And it doesn't matter the order you write them in because we're adding. You could have put the 4x first. So I'm going to group the first two and then group the last two. What's in common? The 3x. What's left over? X plus 2. In the second 2, I'm going to divide out of 4. What's left over? X plus 2. Perfect. Our parentheses match up. That means we can factor it out. Once we factor it out, what's left over? 3x plus 4. And that is our answer right there.